Hi guys, just a little video. In a few minutes we'll pick up with our chapter 13 stuff. It's all brand new. I hope everybody's doing well. It's hard to believe it's already almost the end of April. I hope you guys had a happy Earth Day too. I know my girls and I made some Earth cupcakes tonight, so we had a lot of fun with that. My 3-year-old has requested that I show you a new toy every time I make a video. Kind of like a guest star of the week. So this week, we have Godzilla. That's one of her favorite toys ever. She's off screen making faces at me, but she really wanted to show you guys Godzilla, and I will tell you that it really hurts when you step on his tail. So that's that. Something to make you smile. And we're going to pick up now, back to business, with chapter 13. 13.1 is tough. There's a lot of different pre-algebra concepts. We're kind of learning how to do some algebra stuff, and it's going to take us a little bit of practice. So it's no problem that we're going to kind of pick up and retry and give it another shot. It's going to take a little while for us to get the hang of it. So I have made a study guide that I'll give you as a PDF in its entirety. The study guide or the corrections for Tuesday's answers are also split up and put piece by piece into the Google form that you're going to be working with today. So in the Google form, you're going to look at stuff from Tuesday, see what the real solution should be or how to work through it, and then try a very similar problem right after that. And I'll go through some things in this video. You can pause this, rewatch it, go back to it, look back at the notes while you're answering the questions. I do want you guys to make sure you're doing this on paper in your math notebooks or on a piece of paper. This is definitely stuff we can't do just in our heads. So a lot of really small things like negative signs, that was a big thing that tripped us up on Tuesday. So we definitely want to make sure we're showing that on paper. Okay, so I'm going to try and switch this over to our answer key here. 1 second. Almost got the hang of this technology here. Okay, so this is what you guys are going to see split up into chunks on the form from today. I'm going to do some of these problems under the document camera. Some of them we can just talk about. For example, this first question had you identify the like terms in the following expression. So if we look at the expression, there's 1, 2, 3, 4 terms. And I think probably most of us could have said, okay, there's 4 terms here. But what tripped us up was some of the positive and negative signs. So what's really important to remember is that when you talk about a term, the sign is like the first name and the actual stuff is like the last name. So this isn't just 2r squared, this is actually a positive 2r squared. This isn't just 7r, it's plus 7r. This isn't just r squared, it's minus r squared. This term is not 9, this term is minus 9, and that really makes a difference. So if we look at our choices, some of them that tripped you up here, the closest one to the right answer was this first choice right here, because it has r squareds with r squareds. It has 7r by itself and 9 by itself, meaning, okay, we see r squared and r squared go together. They're like terms, same variable, same exponent, but it's almost like a typo, except this is what was meant to trick you. There's no minus sign in front of the r squared. So the r squared really is not a term up here. It's minus r squared. It should be typed right here, and it's not. So that brings us to actually our correct answer is over here, and we see, okay, it's very similar, but there's that minus sign in front of the r squared. Okay, so I think that was the main highlights from this problem. We're going to go over some of the highlights, some things I saw in common misconceptions, things that are easy to mix up or that I saw looking at your responses. I did leave you guys, in some cases, some private comments on different questions. Make sure you read those and make sure you read all of the stuff that's in red here as you're working through the quiz. On this next question, which ones are true? This one says P's and Q's are like terms. Well, that can't be true. They're not the same variable. The second term, I want to make sure the second part that we are clear on, 4P and P are like terms. This says they're not like terms because they have different coefficients. Well, like terms always are most likely going to have different coefficients. That's the number in front of the variable. That's okay. So that's like, if you remember our silly stories, this silly story would be like 4p, 4 pancakes, and you have another pancake. Pancakes and pancakes go together, and the coefficient tells you that you have 4 in this stack and the invisible one single pancake over here. Okay, so let me keep going here. All right, so this is what, we saw a lot of. So a misconception is that, like we just said, the sign was not included with the terms. And that messes us up when we go to combine like terms in a few minutes. So I put this diagram together to show you the full terms include the sign. This term is not 3. This term in green is a -3. So not this, this. All right. Okay, so let's look at the next question. This is the next big idea that we want to work on, is changing anytime we see subtraction into addition. And the reason for that is when we go to combine like terms, it's a lot easier if we know that we're adding all the coefficients together, because we can use our rules for addition. So if we look at this expression, I do see a -2 and a -g. So my first step, and we're going to go over this in a second, should be to take that minus sign, and instead of a -2, I'm going to put plus a -2. That's the same thing, but the notation makes it easier to combine like terms in a few minutes. So this, instead of -g, should be plus a -g. That's the first step. It's like rewriting the problem the way we need it to be. The second step would be do distributive property if that is in the problem, which it's not in this one. And the third step would be to combine like terms. This last one was kind of the left field answer, multiply 3 times g. Well, we don't know what g is. We're not evaluating this expression. Okay. Now for this question, we're going to put all those pieces together. So it says simplify the expression. All right, so before we can do that, we need to rewrite any subtraction as addition. So if I look, all right, no subtraction, nope, nope, nope. Okay, -2a. So I'm going to change that, and I put it in colors, to plus -2a. Subtracting 2a and adding a -2a are the same thing. And then don't forget about the plus 4.2 over here. All right, now that I have that done, my next step is, if there is distributive property to do, then I'm going to do it, which there is, because there's something outside of parentheses. And the things in parentheses can't be combined anymore. Okay, so I'm going to do the 6 with the a and the 6 with the 2. That distributes the 6 over both terms in the parentheses. So 6 with a, 6 with 2. And then recopy the rest of my terms over here. All right, now I'm going to multiply out. So 6a plus 12 plus the rest of my terms over here. Now that I have kind of everything in the place it should be, I'm going to think about combining like terms. And you guys are going to see in this whole document that I made some of the like terms. Blue, blue and blue go together, and orange go together. And blue and orange are actually opposites on the color wheel. So that just reminds us that, hey, look, we can't combine like terms, things that aren't like with each other. So blue can't be combined with orange. So then we have 6a over here. And this is where it kind of became important about our minus sign. We have a -2a. And when that's really, really important, because if we don't have that minus sign, we don't know if this is 6 apples plus 2 apples, or if this is 6 apples minus 2 apples, or like, is it going to be 8a? Is it going to be 4a? Like, which one is it going to be? So the minus sign tells us 6 plus -2, which gives us 4a, and then 12 plus 4.2, which gives us 16.2. Final answer, 4a plus 16.2. They don't go together anymore. We can't make that like 20.2 a, because that's like 4 apples plus $16.20. They're not like terms. Okay, so that wraps up that question. And this is a little chart, little graphic that I put together to show you exactly what we mean by change those pluses, minus signs to pluses. So 3x, all right, that's fine, leave it alone. -4, I'm going to rewrite that in my new next line of work as 3x plus a -4. -2x, I'm going to rewrite as plus -2x. +5 +5 minus x, the same thing as plus a -x. And then you're also going to see that there's a lot of parentheses in these types of problems, and we know that that's also just to help us see negative signs better. It makes it a little bit easier visually. Okay, so we'll talk about this problem and then I'm going to do a couple on the document camera. So here's the expression 8 plus 4a plus 6.2 minus 9a. So if we run through our checklist of things, the first thing we have to do is change any subtraction to addition, which you can see I did here in red, so plus a negative 9a. So that gives me that little term right there in red. It's like its own nice little package there. And now after that, I'm going to see if there's any distributive property, which there's not. So I'm just going to go right to putting together like terms. So I have constants like 8 and plus 6.2, plus 8 and plus 6.2, and 4a and minus 9a. So if I put the constants together, I get 14.2. I knew to add them because this had a positive sign or a plus sign. And then 4a minus 9a. So we have to think about that. We're just going to do 4 minus 9 and stick an a with it. So 4 minus 9 is a negative 5. And we know that 4 plus a negative 9. You guys remember, I'm sure you miss hearing it all the time, DSD, different signs difference. 9 minus 4 is 5. Stick a negative sign with it because that's the farther distance from 0. That's why that's minus 5. So we put that all together. We get 14.2 plus a minus 5a. We look over at our choices. It's right there. However, I want you guys to be aware that you could also write this very same answer either of these two ways over here. They would be equivalent. Okay. All right. Now these ones, as we start to get into some more steps, they're all written out here for you and color coded with the wording next to it and with what answer is correct. But I'm going to switch over to the document camera now. Let's see. I really hope this is recording because that would be a shame at this point if nobody heard me. Okay. All right, so we're going to go through this next question, which has a little bit of everything, and especially distributing with a negative sign, which is something that I wanted to practice with you guys. All right, so if we look at our expression, the first thing we want to do is change any subtraction to addition. So 4p, and instead of minus 5, we're going to make that plus, but we can't put plus 5 because minus 5 and plus 5 aren't the same thing. We're going to put plus a minus 5. So what I want you guys to see is that these two things are the same. Minus 5 and plus a minus 5 are the same thing. And then in parentheses, we had p plus 6. Okay, next thing we're going to do is distribute. So 4p, recopy. Now, minus 5 times p. So that's going to give me minus 5p. And now minus 5 times this whole term, okay, which is 6. So a minus 5 times 6. And this is where we have to remember our rules that we've been working on a lot this year and especially recently in the past couple weeks before we left for break and then after. So minus 5 times 6 is a minus 30. It's a positive times a negative or a negative times a positive. So it's a negative. All right, so now I'm going to see what I can put together as like terms. So I could use some different color markers. Let's see here. It's handy to have so many kids' crafts laying around. So we're going to have 4p and minus 5p, which gives us a negative 1p. And then we had minus 30. So that just goes by itself. So that way you guys can see where those are coming from. But then when we look at our answer, I don't see a minus 1p anywhere. So we know if there's a 1, that's the same as just p. And we know if there's a minus 1p, that's the same as just minus p minus 30. Okay? All right. So let's look at the next question then from Tuesday. These are all the problems you guys did on Tuesday. So that's where these are all coming from. It should look familiar, hopefully. If it doesn't look familiar, I don't want to know. Okay, so for this question, first we're going to look and see if there's any subtraction. There is, so we're going to change that to a minus sign to a plus. So instead of minus 9, we're going to do plus negative 9. And this guy over here. All right, so now we have negative 2/3 this number outside of parentheses, times this, negative 2/3 times that. So when we just want to multiply these two things together, we want to do the coefficients first, the numbers first, and stick a c with it. So a minus 2/3 times 12. So 2/3 of 12 is, go ahead, I'm giving everybody time to catch up here. 2/3 times 12 is, well, let's do it out on paper. Cancel. 8/1. So because one of them's negative, that's a -8, negative times a positive, 2/3 times 12, and stick a c with it. Okay. Now we have minus 2/3 times -9. And you see we're changing that and making it its own little compartment with the negative kind of maybe helps us see that, whereas I think a lot of us missed that before. So now we have a minus times a minus, which gives us a positive plus sign. Positives and plus signs are the same thing. And 2/3 times 9. This is all the work that I would want to see on your notebooks. At one point, maybe we'll get tech savvy enough where you guys can upload your work, but not quite there yet. So negative 2/3 times -9, positive 6. There's no letters, so that's it. Recopy this guy. And then we think about our like terms. Minus 8c plus 14c. So that's like you have 14 carrots and you eat 8 carrots. How many does that give you? You guys should eat your carrots. They're good for you. My kids don't eat carrots, but okay. 6c plus 6. All right, final answer. Those two can't be combined anymore. And I had one more problem that I wanted to do with you guys. After this, most of the other ones from Tuesday look pretty good. These were the more complicated ones. So, all right, so we have this. We're going to set up anywhere we see subtraction. We're going to change to addition. See what I did there? -3 plus a -3. C minus 5. Recopy this guy. And now distribute -3 with C. -3 with C is -3C. -3 with -5. That's where we really have to be careful here. And that's why I wanted to show you guys this example. When we distribute here, it's this thing times this. All right, that was easy. Now we got that. But now it's this thing times this. And a lot of us might have put down -15 by accident, or we put +15 but didn't really understand why. So now -3 times -5 gives you +15. There's my annoying dog. He's like a foot tall but thinks he's a Great Dane. Okay, and now we're going to put together our like terms. So 8c minus 3c gives us 5c plus 15. Final simplified answer. Okay. All right, now I'm going to switch back to our document. Okay, we just went through these questions, but you guys have this that you can read over at any time over and over again. I gave you some notes about what we just talked about with the distributing the negative sign. This problem that we just did on the document camera is actually this one right here. That's not one you had on Tuesday, but that's part of the notes I just gave you. This question in general, I think some of us got wrong, which one is equivalent to 2x minus 1, because we didn't try each of these 4 choices. So you really can't answer this question. This is one like of those that we call a 4-for-1 problem. It's really 4 math problems in one. So math teachers love this kind. You guys probably hate it, but you have to do this one, this one, this one, this one in the 4 boxes. All of those steps that we just talked about, negatives, distributing, and combining, before you can find which one is 2x minus 1. So I'm not going to go through that step by step right this second, but we got to make sure we're showing that work there. These ones, the rest of them look pretty good. So what it means to be fully simplified, we did a good job with our perimeter, I think because that was all adding, so there weren't any negatives to trip us up here. We did the age problem. It helps to write it out. Danielle, the sister, and the brother, and then put them all together. And then I saw a lot of good things too with the last question. There's different ways you could think about it, and I kind of put those out there. But I think everybody got that X was the number of hikers, and you have to have a sum of the weight times X. And when you simplify that, you get 10.2X. So that kind of wraps up that document from Tuesday. And you guys will work through the very same type of questions interspersed in the Google form. So I want you to be pausing the video, rewinding the video, reading the information, and really kind of giving it your all here. So I'm going to pause this for a second and then switch over to your, well, maybe I'll leave you in suspense. Nah, I'll show you. So we're going to switch over to your fun answers from Friday. I had a lot of fun looking at what you guys said, so I'm going to pause this while I get over there. Okay, so I am back, and I have in front of us our Friday assignment from last week. So you guys will see these more frequently. I think they're a lot of fun. The math teachers have enjoyed putting these together. So again, there's no necessarily right or wrong answer, but it's all about your justification. And even better if you can kind of relate these things to math, but you definitely don't need to in some cases. So this was the question, if you guys remember, the Pringles, the Oreos, that's been kind of my quarantine diet here pretty much so far, pancakes and poker chips, so which one does not belong? So I'm going to switch over to our responses here just to show you guys. The overwhelming majority of the class said that the poker chips do not belong, but I think even more interesting than that was what some of your responses were. So I'm gonna, if you guys can see that here. A lot of people said because the poker chips are not edible, they don't belong with the other ones. But a couple people talked about shape, which was kind of interesting, and the way that they stack. So in other words, the Pringles weren't round and perfectly circular, or that the pancakes didn't stack perfectly. This one I never even thought of, that the words Pringles, pancakes, and poker chips all start with the letter P. So that's definitely a good reason right there. Somebody threw an emoji in there. That's actually my favorite emoji ever, the crying, laughing face. Pretty much sums most situations up, at least in my situation. So you guys can see some other ones here, just to give a couple shout outs. Poker chips, the poker chips don't belong. Food, edible. Let's see. The stack of circular things. This person talked about quantity. So because the chips were thinner, there was a lot more of them. And there, I think that's everybody. So again, look out for those guys. This is what we're looking for though. Pick your choice and then give us a justification down below. So we'll give you a little Friday shout out from here on out. So that pretty much, that wraps it up, guys. If you're still listening, maybe because your parents made you, I don't know. But I hope that you're pausing the video, you're going back and watching it. I hope you're looking at the examples, really giving it your best work. Make sure that you guys are showing your work in your notebook. Just because you don't have to type it doesn't mean you don't have to show it. So make sure that you're doing that. And I hear a 3-year-old breaking out of her room. So I think that's it for today. Hope everybody's doing well. Let me know if you guys have any questions.